Hello everyone, welcome to this session on Introduction to Concrete Design Workflow. I am Surajit Ghosh, I am a structural engineer. Let's quickly go through the agenda that we are going to cover today. So this is not a detailed technical session, so I'll not go through what are the design requirements or how we are performing the beam, column or shear wall design, not something like that. Rather, what we'll do is that we'll let you know what is the complete workflow that we can follow in STAAD or in RAM structural or in using any other Bentley structural products that might help you to solve your concrete design solution or to model your structure very quickly. For example, this is the agenda that I have planned, and what I am going to show you is that first I'll show you what are the structural products there under the structural worksheet license which can be used for the design of superstructure as well as for the foundation design. So this session is planned only for the RCC building. We are not covering the steel design part, so I'll select only those products or talk about only those products which will be used for your RCC building structure. Then I'll cover how we can transfer the data from architectural model to structural model, and finally we can publish the data as a deliverable format, means the drawing files that can be published and directly sent to the site so that they can start working on this particular drawing. Next, I'll cover some of the parts, means what are the different components we can design using the structural worksheet product. For example, like using the STAAD or using RAM structural system. What are the methods we can model it, and what is the quickest option to model it and perform the design. So I'll cover that one. And finally, I'll go for some advanced analysis topic like the construction stage analysis or the drift control. So this part is not required for a small or medium scale structure. For example, like if you are going to perform or if you are going to design a G plus 10 story structure, then probably you don't need the construction stage analysis, or you don't want to perform the drift control. But if you want to perform a very tall structure like G plus 50 story structure, then this type of advanced analysis is required. And at that time, you need to perform this one, and you need to perform or you need to submit the report for this advanced analysis. So that part I will cover. I'll just provide guidance or the workflow how we can perform this. Okay, so this is the agenda, or are the topics that I am going to cover today. So let's start. But before going into the details, before going into the workflow, I just want to talk about what are the means. You can ask me obviously that whether we are just providing this information as a suggestion, or if there is any practical usage of this one. So that's why I first included few of the case studies. Several of our clients, probably heard about the YII, year in infrastructure award. So several of our clients used our product to complete some of the projects. For example, like WSP Group has used RAM structural and RAM concept for the design of the STAAD at London. So this structure is basically designed or modeled and designed using RAM structural system, and later the flow diaphragm is modeled and designed using the RAM concept part. So this is one of the example that we always provide. And similarly, there is another product designed by the same group, that is the 22 Bishopgate. This is also in the London. And the main thing of this structure is that they have tried with several, almost 70 different geometric options. Means they have modeled 70 different instances of the same structure and finalize which type of structure is most suitable and most economic for this building. So they have used RAM structural system along with RAM concept for this project. So you can find several other projects there. If you just go to Bentley site and just go for the YII, you can find there are several other projects or that has been already published, that has been already sanctioned, and some of these buildings are already there, means already it is constructed. So for example, one example is the Admiralty Arch in UK, which has been used the RAM concept and Plaxis to build a new basement. So it's a multi-story basement that they are constructed just below this iconic arch. Also, there are several other examples like the Dhirubhai Ambani Convention Center in India, the Burj Al Fardan in Qatar. So they have used different structural products. So this is not something that I am just going to tell you from an assumption. Rather, whatever I am going to show you in next 30 minutes, that is a approved workflow that I can say, and several of our clients are already using this workflow. So you can trust this workflow, that I can say. So before going into the workflow, I just want to inform you about the products that are available under the structural worksheet. So as you may know that structural worksheet is a bundled products. There are 9 different structural products which are bundled together under a single license that we called structural worksheet. And it basically comes from the products from STAAD family along with the products from RAM family. So what are the products that I am going to show you? But just for your information, that structural worksheet is not a single product. It's basically a license, and there are 9 structural products that are used or that are combined together under this license. So the first products which are there is the STAAD line of products: STAAD.Pro Connect Edition, STAAD Foundation, STAAD Advanced Concrete Design, and RCDC FE. STAAD.Pro Connect Edition, you already know about this one. This is the 3D structural analysis and design product. STAAD Foundation Advanced is basically one product that is very good for the foundation design. Whether you want to perform a isolated combined pile cap or the mat foundation, or any tool, any planned foundation like the vertical vessel, horizontal vessel. So STAAD Foundation Advanced can be used anywhere to design any type of foundation. Then we have the STAAD Advanced Concrete Design or RCDC mode, which is very good and is our only one and only advanced solution for the concrete element design, whether that is beam, column, shear wall. Also, it is now equipped with the tank design. So tank design as per EC2 code is already implemented there. And finally, we have the RCDC FE, which is a finite element software which can perform your slab and mat foundation design using the finite element analysis results. So these are the some of the products from STAAD family, and then we have the product from the RAM family. We have RAM structural system, which is a very good software for the building structure. So if you just ask me that what is the best software that we have under Pendless portfolio for structural product for building structure, so RAM structural system is our best product for any tall or medium to tall structure design. So I'll show you some of the examples where we can use the RAM structural system. But it has some of the great capabilities like the construction stage analysis, drift control. There are multiple diaphragm like the pseudo diaphragm or the flexible diaphragm. All those systems like the outrigger truss or the belt truss, all those type of system which are required for the tall structure design is already equipped in RAM structural system. Then we have the RAM concept, which is a product which can perform any type of slab design, whether that is a elevated slab or mat foundation, whether that is a PT slab, whether that is a hybrid slab, flat slab, any type of slab can be designed using RAM concept. So this is a very short description, and these are the 9 products that comes under the structural worksheet license. And today for this RCC workflow, I am going to use several products from this list. For example, for superstructure design, I am going to use STAAD.Pro Connect Edition, STAAD Advanced Concrete Design Mode, then RAM Structural and RAM Concept. So these products will be used in the complete workflow of concrete design. And for foundation design, I am going to use STAAD Foundation Advanced and also the RCDC FE. So these are the products that I am going to showcase in my presentation today. And just want to inform you once again that this is a workflow. I am not going too much technical details, but if you want some technical information about any of these products or about any of the element design like shear wall or slab design, then you can let us know and we can arrange a webinar, detailed webinar later. So I have discussed about several products. Almost 9 products are there, and if I want to perform a building design, RCC building design, what is our choice? That is the first thing that always comes into our mind. That there are 9 products. If you talk about the superstructure design, we have multiple products. So what is the product that we are going to select for our building structure design? And I have categorized some of the products under these 4 categories. So if that is a very small structure like a building up to G plus 10, 20-story building or 25-story building, then you can use STAAD.Pro plus RCDC or RAM structural system. RAM elements also you can use, that's not a problem. For any building structure that is up to 50 story, so you are increasing the complexity level of the structure. There are some components which are not present for the small structure but will be present for a large structure. Then you need to go to a RAM structural system, because as I have mentioned that there are several advantages of RAM structure, like we can perform the wind tunnel test data. Means we can directly provide the wind tunnel test data in RAM structural for the wind analysis. So these type of advanced facilities are there in RAM structural. And if we want to go for a high rise or tall structure design, then obviously our first preference will be RAM structural system. But up to G plus 50 story building, you can either use RAM structural along with RCDC, or you can use STAAD.Pro along with RCDC. So that's up to your choice. Both software are capable of doing this one. And today in my presentation or in my workflow, I'm going to consider these two type of structure. So the buildings up to G plus 50 story, because if I want to go for tall structure design, then there are multiple things I need to specify. And clearly we don't have that much of time in one presentation. So today my session or this presentation will be limited up to G plus 50 story building. And if we want to talk about the foundation design, so this is all about the superstructure design. Now, if we want to go for the foundation design, normally for any high-rise structure, we need to go for mat foundation design or mat with pile. But still, if you want to go for isolated pile cap or isolated combined footings, then you can use either STAAD Foundation Advanced or RCDC. If you want to perform or model your structure in RAM structural, then we have another choice there called RAM Foundation that is only integrated with RAM structural. But if you want to model your structure in STAAD.Pro, then the best choice would be using the RCDC or STAAD Foundation Advanced mode to design this type of foundation. And for mat foundation design, obviously, if we talk about any high-rise building structure, then obviously there will be mat foundation along with the pile cap. Means along with the piles. So if there are multiple basement, you need to go for mat foundation. So for mat foundation, we have multiple choice. We have RCDC FE, we have RAM concept, we have STAAD Foundation Advanced. But there are some differences. For example, if you want to model your mat foundation along with your superstructure, then you can use RCDC FE or STAAD Foundation. But if you want to model the mat foundation along with your superstructure and want to assign only support or fixed support there, and finally during foundation design you want to model the mat foundation, then you should go for the STAAD Foundation Advanced. So there are multiple choice depending on your project type, depending on your structural requirement, you need to select the product. And finally, this is some of my old projects. So I have already designed some of the projects using Structural Worksheet. In some of my project, I have used STAAD.Pro plus RCDC, and in some of my project, I have used the RAM structural system. So that totally depends on the structure, that totally depends on the loading that we are going to assign, or the structural system that we are going to model. So depending on your requirement, you need to perform your design or you need to select your product. Okay, with this, I am done with the product selection and a brief discussion about what are the capabilities of each of the product. Now I am moving to the next part, which is the main topic of today's discussion, is the data interchange and interconnected workflow. So let me start with the STAAD.Pro. As you know, STAAD.Pro Connect Edition is there in the market since 2017. And if you go open the STAAD.Pro Connect Edition interface, you can find there are now three modelers. The first one is the analytical modeler, which is also present in the older version of STAAD.Pro V8i. Here we can model each of the structure or each of the component as an analytical member, and we can perform the analysis and design in this analytical modeler. But there are two other modelers which can be used for the RCC building design. One is the physical modeler, where our entire approach is from the physical entity. Means you don't have to think about the interconnected or the internal nodes. Suppose there is a primary beam, there is a secondary beam. We don't have to think about how the primary beam is connected with the secondary beam, or if there is any shear wall along with a slab which is modeled with finite element mesh. We don't have to consider, or we don't have to bother about the wall slab meshing. Everything will be governed internally by the program. So this is one of the advantage of physical modeler. And third, we have the building planner mode. If your architect provides you the floor plan, suppose for your G plus 10 story structure, there are three typical floor plan. One is for the plinth level or the ground floor level. One is for your typical floor. that is going from the first story to ninth story, and finally you have another typical floor plan which is for the roof. So you can just import these three floor plan directly in the building planner mode, and you can just inform program, okay, this floor plan is associated with this story. So program will stitch all the floor plan and create your 3D structure. So this is one of the advantage of building planner mode. And this is basically very good for the RCC building structure. So as I have mentioned, there are three different modeler in STAAD.Pro, and along with that, if we consider about the RAM structural system, there also we have a separate modeler. We can model the structure from plan view, and we can stitch all the floor plan to create this type of 3D structure. So this is one of our old project. This is a 42 story building structure that we have modeled using RAM structural, and I will discuss about this structure at the end of my presentation. But as I was saying, we can model it from the scratch either in the STAAD.Pro Connect Edition or using the RAM structure. But think about the practical application. So when the architect plan the external surface of this particular model, any model, so they think about something. They create the model in any of the architect product, like the Open Building Designer that we have in Bentley or in Revit. So they create the model. For example, this structure is created using the generative component part in Open Building Designer, that is with Bentley systems. So they normally create the model and provide you the details of this model data. For example, what is the floor plan, where the column and beam are located, what is the area, everything they will provide. And finally, we use that particular plan or that particular information, architect information, to create this model from scratch in STAAD or in RAM structural system. So this is normally what we follow in our industry. The architect creates the 3D model of the architectural model that you can say. They provide some of the information that are required for the structural modeling purpose, and then we use that data for the structural model generation. Now there is a problem. For example, just consider about one scenario where the architect at some later stage move a column. Some column are relocated, or they change something, or they change the shear wall opening, they move the shear wall opening, something like this. Some structural components has been changed. It is very normal, and if you are working with any live project, then you are probably know about this problem, that you have already created the structural model. Now the architect mentioned that, okay, this is not something we are looking for and we need to change something. There is another scenario. For example, during the design, you found that, okay, the column dimension that is set by the architect, that is not sufficient, and we need to change the column dimension, or we need to convert it to some shear wall that is more economic. So in that case, that might hamper the architectural beauty of the structure. For example, you are converting one column to a shear wall, but there is a window which we need to shift, and you need to inform the architect that, okay, this window will not be there anymore, and you need to shift that one. Now there is a real challenge to incorporate this change in the architectural model or in the structural model. And basically there is no link between them. Architect provide you the floor plan, you created the model from the scratch, and you cannot interchange data from your architectural model to your structural model. So how about a interconnected workflow where you can reuse the data of the architectural model? You don't have to create the plan or create the structure once again from the scratch. Rather, you are going to use the data that has already been generated by the architect, and you want to import some of the data to your structural model. And similarly, you want to export some of your data to your architectural model. By this interlinking workflow, you can achieve something which is not possible using the if you want to start the model from scratch, and that can be achieved using the ISM interface. So I'm not sure whether you have heard about this ISM or not, but it is there in the Bentley products since the last decade. And basically, this ISM is nothing but a common basket where you can dump some information. That might be some architectural information, that might be some structural information, and you can gather the information or import that information in your structural model. And this is not only between the Bentley products, but we have a very good connection with Revit, Tekla, and also the Open Building Designer. So if you generate your model in Revit, you don't have to create the model once again in STAAD or RAM. You can directly import your Revit architectural model to STAAD for the analysis and design. And later, if you change something, that can also be imported in your architectural model. So I have just show you a quick example. So this is a example file of Revit. I think if you are working with Revit, you are very aware of this problem. So for this example, what I am going to do is that I am going to transfer the data to STAAD.Pro. So this 3D model is already generated. What we need to do is that we need to install ISM Revit plugin in Revit, and then we need to export the model to ISM. So for ISM, it is a .ism.dgn file that we can export to ISM. And once this file is exported, we can just import this model instead. So the process is very simple. You need to select the components which you need to export. And this is basically the ISM interface or the structural synchronizer interface where we can review the model. So you can export everything in ISM. And in ISM, we can filter out what are the structural components and what are the architectural components. For example, there is a temporary wall that we don't want to model in our structural product. So we can check the visualization in structural synchronizer. We can isolate the components which are required for the structural analysis and design. And then what we can do is that we can open our physical modeler or analytical modeler of STAAD.Pro, and we can simply import that particular ISM file. And what it will do is that it will import all the structural information, means whatever you have selected in the ISM interface. So you have the choice to select some of the components or reject some of the components from the ISM modeler. And once you select and import that model, you can see everything, every structural information that is there in your Revit file or that is there in your ISM file, that is imported in STAAD.Pro. So this is not a plain structure, but actually that is a finite element meshing, and also the meshing is imported in STAAD.Pro. So you don't have to create this floor plan once again from the scratch. Rather, you can just export the model from Revit to ISM, and from ISM you can just import this model. And this is basically the ISM. This is basically the STAAD.Pro analytical modeler, where you can find that each and every information, structural information, that is beam, column, the slab, shear wall, every information is already imported in STAAD.Pro. Now you can readily start working on this one. So if you think about creating this model from scratch, you easily understand that how much time it will require. And not only this, that all the offsets, all the property values, all the offset, everything is imported. So if there is any slab offset that is already assigned in your Revit model, that offset value is also imported instead through ISM. So this is one of the importance of this particular ISM interface. And this is what we called as the interconnected workflow, that we don't work with separate modules. And once you are done, once we have changed something in the analytical modeler, we can just dump that information once again back to architectural model or ISM file. So this is a two interconnected workflow that we say, and this is a two-way interchange. So this is not from Revit to STAAD or Revit to RAM structural system. Rather, it is Revit to STAAD, then STAAD to Revit again, once again, or OBD to STAAD and then STAAD to OBD once again. So this is what we called as the interconnected workflow. Now, once you land in STAAD.Pro Connect Edition, then what? Then we have multiple options within the same environment to model or to design your structural components. For example, this structure, this is a G plus 14 story building structure that I have modeled. So this model is done in STAAD.Pro. We have used the building planner mode to create this structure, and then once the analysis is covered or complete, then we can perform the foundation design using this foundation integrated foundation design interface. We can perform or we can generate the deliverable drawings, the grid drawing files directly using the steel autoadapter mode. And don't go with the name steel, because this is a common mistake. This is not only for the steel, rather you can use this interface also for the concrete structure. So we can generate this type of grid drawing file directly from the steel autoadapter mode. We can perform our concrete element design, beam, column, shear wall, slab, everything we can perform using the advanced concrete design mode that is also integrated with STAAD. And finally, if we want to go for PT slab design or the hybrid slab or the flat slab design, we can use this advanced slab design mode or the RAM concept mode. So all these modules are interconnected with STAAD, and all these modules just use your STAAD.Pro geometry and the analysis results to perform the design. You don't have to once again create the geometry there or apply the loads. No, you don't need that one. Rather, you just need to export the model to these modules. And all these modules comes under the Structural Worksuite license. So if you have the Structural Worksuite license, you can use all these interconnected modules. And today I am not going to cover the other modules. I am going to cover only the single module, that is the Advanced Concrete Design module, or the RCDC mode. RCDC has a great capability of designing any type of elements, whether that is beam, column, shear wall, slab, pile cap, some of the footing. And recently we have imported or included the water tank design using the EC2 code. If you want to perform the design of the beam, column, or shear wall, you can just export your model to RCDC mode, and there you can perform your concrete design. And one of the great feature of the RCDC is that you can design any type of column, whether it is a T column, L column, amoeba shaped column, or that is a flange column. Any type of column, if you just model it, RCDC can design it. That is the basic of RCDC. There are multiple international design codes that are already there. It's Indian code. We have the IS 456 plus 13920. We have the latest version of ACI code. So ACI 318 to 2019 version is already implemented in RCDC. So if you want to use that one, it is already there. We have the British code, we have the Euro code, and there are multiple national annex of Euro code is already implemented. And not only that, if you want to use some of the annex which is not there, then we have a custom annex option where you can provide the information, and depending on that, it can perform the design. And finally, we have also the Philippine code and water tank design as per the EC2 code. So there are a lot of design codes which are already there, and we are also still enhancing the design code. And it is not only connected to STAAD, rather it is also connected to RAM structural system. And also you can import your, if you want to perform your modeling in ETABS, you can also import that one for the design part. So I just want to show you a very quick example how we can do that one. So this is the same structure, that G plus 14 story structure, and you can find that there is a CR code. I have already modeled the beam and column system. And once the analysis is complete, we can just click on this Advanced Concrete Design tab. You can find that there are multiple options, the licensing options. If you have the Structural Worksuite license, you can use the full feature, or you can use the partial feature of the RCDC mode. For example, I want to design the column and shear wall. So I can select the design code. For example, I am going to use the IS456 code, or if you want, you can use the ACI 318 code. So this screenshot is not updated, but now it is the ACI 318 2019 version code is also available, as I have mentioned in my previous slide. So you can select the design code, and if you want to use that one, this design code, you can find that all the information, means the geometry information, the loading information, all are directly imported from your STAAD.Pro model. And once the modeling, once all this information are imported, then we are left with the design of this column and shear wall. So everything is there. Now we can just specify the design parameter information, the effective length parameter and everything. And we can perform the shear wall, column, and every design. You can perform the design directly in this environment. And once the design is done, then we need to generate the deliverable drawings, or we need to generate the template file for the design output. So first of all, RCDC generate a very good and detailed design results in the tabular format, which you can copy. And also, not only that, it will also provide you the failure diagnostic. So if some of your member fails, then it will inform you about what is the reason of this failure, and accordingly you can check or rectify your problem. So it can provide you that, okay, your column fails because due to the detailing ratio, or the percentage of steel, the PT percentage is over your specified limit. So that you can specify, I means check from here, and you can rectify your model along with that one. It generates a very good and detailed drawing. So this is the shear wall that I have modeled. It's a column plus shear wall combination, and we can generate a very detailed drawing. We can save this drawing file in CAD format. So if you want to modify this drawing file, so you can just save it in .dwg or DXF format, and later you can just modify this drawing file. Along with that, it generates a detailed drawing for the plan, elevation, everything, and also the BPS file. So this is one of the beauty of RCDC, that it automatically generates the bar bending schedule for you. So you don't have to need to change anything. If you're at any time your design change, then the bar bending schedule is automatically updated. So you can export this as a CAD format, and you can use that with your project report. So if you want to generate the BBS file, you don't need to send your reinforcement information to your draftsman. Rather, you can directly generate the bar bending schedule directly from here. Okay, and finally we can design the flange beam, like if there is an T beam or L beam where we need to consider the effect of the slab, we can do that one in RCDC, and program will design the beam considering the slab stiffness. And finally, this is another point which I like very much. It is the update design and update analysis model. Means once we have performed the design, we find that this column dimension that we have estimated is not sufficient. So we need to change that one. There is a 500 by 500 column that fails. We need to change it to 700 mm by 500 mm. So we can change that one in RCDC and check that whether it pass or not. Now we can directly update our analysis model using this changed column information. So this is one advantage. We don't need to copy or note down every change that is made in RCDC during design and then go to the STAAD.Pro or STAMP structural model and change the model size from there. No, not like that. But you can automatically update your analysis model directly from the RCDC mode. And not only that, if you have performed the column design, the beam design, the slab design, you can import that data directly in your single module of RCDC, and you can generate a combined drawing file with that one. So that is also possible. Finally, if you want to go for the advanced analysis, for example, you want to perform the construction stage analysis, you want to perform the drift control, or you want to perform the design for the creep and shrinkage, what is the solution? These options are not there in STAAD.Pro. So if you started your model with STAAD.Pro and finally find that, okay, I need to perform the construction stage analysis. So the option is not there in STAAD.Pro, but that does not mean you cannot perform the construction stage analysis. What you need to do is that you can transfer your model directly to RAM structural system. So as I have mentioned that ISM can be used to transfer your model from one module to another module. It can be from architectural modeler to structural model. It can also be transferred between different structural modeler. What you can do once you have performed a design, you want to check how the drift control will behave or how you perform the construction analysis. What you can do is that you can transfer your model to RAM structural system using ISM interface, and in RAM structural system you can perform the construction stage analysis. So this is a very short example. So this is the 42-story structure that we have modeled in RAM structural system. This is a finite element design software. So as you can find there, it performs each and every element as a finite element, means the slab and shear wall element. So if I can show you, so you can find that there is a shear core and all this slab and shear wall meshing is generated properly. So this is generated with finite element meshing, and we have used multiple options or structural components in this model. We have used the dual framing system, the lateral and the gravity framing system. Along with that, there is a composite deck at the top of this structure. There are some outrigger element, as you can see. Also along with that, there is a shear core. So our intention is to perform the design in RAM structural system, means we want to use the RCDC mode for the design, and this model is done entirely in RAM structural system. So as I have mentioned that there is a very good option that is present there, is that we can apply all the loads. For example, if you want to apply the wind tunnel load on directly on the structure, we can do that one. We can perform the analysis directly, the lateral analysis directly in this module, and after that we can go for the design. So it is capable of handling any type of analysis, whether that is the P delta analysis along with the response vector analysis. It can do that one. And another great point of is this one is the construction stage analysis. So as you know, for a large project, all the models, so if there are multiple towers, all the towers are not constructed at the same time. Rather, some part is constructed at some time and then the construction of the next part starts. So this you can see as one example where one part of this tower is constructed at a later time. So in construction stage analysis, we can consider this type of time variant effect, where depending on this construction stage, we can find out what is the final force there. And finally, we can go for the design. So this is the RCDC module that we have used for the design. We can perform the design directly in here. As I have mentioned, that beam, column, shear wall, everything we can perform the design in RCDC mode, which all we can also use the integrated module. And finally, we can go for actually I have used the PT slab here as far as I can remember. So for PT slab design, we can use the integrated RAM concept module or the slab design module. And here we can perform the information, means we can provide the design parameter information, and we can perform the design of this slab as a PT slab or as a hybrid slab. So no, this is not a PT slab, rather this is a flat slab. So this we can provide, and as you can see there, I'm not sure whether you can see it or not. It also provided the shear studs are provided at the column junction. Okay, so this is a quick walkthrough about all the workflow that we have in RAM structural system. And if you want to know more about any of the structural component, how we perform the design or not, then you can just provide your feedback, and we can arrange a detailed session at some later stage.